topic. I hope you're all settled down for the second topic. May I call on once again Engineer Marilu Talyador to introduce our speaker.
Good afternoon. Thank you, Ms. Anika. Our second speaker is more engaged in technical consulting and services with an extensive experience in structural engineering. He is a civil engineering graduate of Rizal Technological University in the Philippines and went on in completing his specialist diploma in building information modeling in the Building and Construction Authority Academy in Singapore. Currently, he is a technical specialist in Trimble Solutions Southeast Asia Property Limited in the same country. To share his knowledge on the topic, integrated digital delivery with Tekla Constructible BIM, let us all welcome Mr. Marvin Josol Garcia.
Hello. Good afternoon, everyone. Sound check. Can someone make a thumbs up whether my audio is clear? Okay, thank you. Okay. Thank you, Ma'am Marilu. Let me share my screen. Wait, sorry, I'm not quite familiar with Zoom. So. Okay, can you see my screen? Can you see my screen now? Is it now reflecting the presentation slide?
Yes, sir.
Okay, thank you. Again, it's my pleasure to be invited on this first PICE Iloilo talks. Yeah, so today I understand you just finished your lunch, and of course after finishing the lunch, most of us are quite full and feel sleepy. So I hope this session would not be that case, but I'll try my best. Okay. So yeah, so for these sessions, I'll be talking about the integrated digital delivery with Tekla Constructible BIM or Trimble Constructible BIM. So I have my sessions would be, first session would be discussion about the slides and some sharing only and some video clips, and then afterwards I have some software simulations on how to create modeling, generation of detailing, drawings, creating a report, and then lastly is the visualizations. Okay, so without further ado, let's start. Okay, here. So yeah, so just a quick introductions. Who am I? So I came from Rizal Technological University. I also took up a specialist diploma in BIM, in the BCA. BCA is the Building Construction Authority Academy, wherein they specializes in all the this kind of diploma courses. And then I also took up the Structural Skills Supervisory in 4SS here in Singapore also. I've been in 17 years of experience in building industry, both constructions, engineering, and software kind of matters. 14 years alone is using Tekla solutions, so I've been quite long using Tekla software. But by the way, I went here in Singapore way back 2010. So after 7 years of my previous company, I joined Trimble as the technical specialist. But before that, I am the former BIM manager of Yongnam. Yongnam is one of the biggest steel fabricator in Singapore, and Yongnam is the one who built most of the iconic project in Singapore, and Sky Park, Marina Bay, and later the Sports Hub. Okay, these are a few. At the same time, also I'm the assistant engineering manager of Yongnam. So we have We have engineering offices, and then we have these joint ventures who handle BIM kind of BIM works. Yeah, like I said, I'm involved in Sports Hub. Some of my slides are taken from Sports Hub slides. Yeah, I'm a seasoned speaker, and I do a lot of technical training, especially under Tekla. And lastly, I'm fond of reading manga, watching anime, and collecting sneakers. Yeah. So if you want to visit me, join with me in my LinkedIn. You can take your phone. Most of the phone now, you can take a camera, and then it will scan. So either Android or Apple, it will directly to my LinkedIn. And if you want to have you seen this? Sorry. Which screen are you seeing? Are you still seeing the presentation slide? Okay, here. If you can see this, yeah. So I have this Sports Hub slide for the if you want to get about the some of the case studies that I work with. Yeah. So yeah, please join with me if you want. Yes. Okay. So let's move on. All right. Understanding first about what is Trimble and what is Tekla. So actually, Trimble owns Tekla Structures. Before, Tekla was owned by a Finnish company in Finland, and year 2016 it was bought officially by Trimble, which is a US company. So let's have a quick one. This is a US company over 35 years of the company. And yeah, so we have the Trimble itself has more than 9,000 employees, and across the globe, 35 countries, and 800 plus constructions professionals, and we have 2,000 patents, meaning developed only specifically for Trimble. And then we have this. We also member of the NASDAQ. The core business of Trimble is split into five. So split into five category. So it would be like this. So agriculture, building, civil engineering and construction, geospatial and transportation logistic. Me myself, I fall under buildings, which is we handle softwares and everything. And then civil engineering, of course, all the heavy equipment. The geospatial is about the laser scanning that was shown a while ago this morning by Sir Lex. But this one is from Leica, right? But this one we have our own Trimble. We call it Trimble navigations equipment that would survey kind of thing, and then it will communicate with the civil. But I am under buildings. Okay, so just to show you the diagram, which is how the building life cycle. These are the common building life cycle wherein it started with a plan, and then it will go to the concept, design, engineering, bid awards, fabrication, construct, and operate and manage. So these are the complete building cycle. So how we in Trimble position this building life cycle is this wherein all of these software that you can see below on each stages are under Trimble family. So if you notice here in the plan, so we process first, begin with the plan. Okay. Solution from the real estate division provide customer with planning tools to determine the strategies to buy. So these are some of them: SketchUp, Manhattan, Viewpoint. Manhattan is commonly in US. Viewpoint, we have some in Southeast Asia. And then after you develop the plan, you will pass it to the decision to build, to create the concept, right? The concept. So the concept is either you use SketchUp if you are an architectural discipline, and if you are in civil engineering discipline, you are using Tekla Structures to do analysis, right? And then after you do that, to develop the concept, you will pass it on to design and engineering, wherein you will increase the level of detail from concept to the design engineering perspective. And then these are some of the software that is belong to the Trimble, like I said, and then pass it to bidding awards. So still the Tekla is still there in this bidding awards, because if you do some biddings, especially if you wanted to award a project, we started with a stick model, and then we may use some of the BIM authoring tool came from architect, from engineering consultant, and then you convert that into native object to create your own stick model for you to calculate all the materials and everything, and then you can have a better bidding. Of course, if you have a better bidding, you may award of the project. Okay. Then after that, you will pass into the fabrication and construct. Still, this stage is now in the level of detail is about 400 or 450, wherein we are now dealing with accurate cuts, bolts, almost everything, and then you pass it to operate and manage for your building as build or FM or facility management. So these are the complete building cycle. So we as Trimble, we're not only handling specific discipline, but we are a complete cycle. But for today, I'll just focus on Tekla because I'm under from the Tekla. Okay, so what is the Trimble constructible process? This all about constructible Trimble. But to give you a better perspective in a short video clip, kindly watch this clip. Let me know if you can hear the voice or the audio. Give me a sec.
With the Trimble constructible process, you can build with confidence using data so accurate.
Can you hear the audio? Can someone confirm whether there's an audio coming in, or maybe it's not too shallow? Wait, how would I know? Wait, there's some comment. Sorry. Okay, thanks. Thanks. Okay. Okay, let me continue.
Every person and team can work together for shared success. So when you look at your final creation, you can sit back and say, I built that. Whatever you can imagine, Trimble Constructible can build. Trimble.
Trimble has been adopting the constructible process with 3 key elements.
I think the internet would not be allowed. Right, still
Connected workflow to bridge the information islands for better collaborations between project stakeholders. Content-enable project team to eliminate guesswork and misinterpretations. Constructible model with high levels of details to provide a means to identify project issues more accurately and make informed decisions.
Apology for the pausing. I think it's because of
In Singapore, Integrated Digital Delivery (IDD) is identified as one of the 3 key components to transform the construction sectors. It aims to streamline the work processes through the use of digital data across the entire project lifecycle. The constructible process and IDD complement each other.
Okay, a while ago, the integrated digital delivery was mentioned by Sir Lex.
The connected workflow integrates the work processes among project stakeholders by
And so these are the one that mentioned by Sir Lex. Maybe I'll pause a while to allow it to play. I think because of the internet, probably because of us. But basically, the IDD is all about like what Sir Lex mentioned, there's a BIM, there's a VDC, and there is a this other kind of thing. So these are communicated with each and other to develop with IDD. So these are our stages. So if I could remember, 2015 it was BIM, and then after 2017 it became VDC, and then Singapore as one of the BIM practitioner in Southeast Asia. So they develop a lot of workflow to improve this kind of stages. Okay.
Utilizing digital content of a constructible model for quality delivery. At the design stage, Tekla enables digital design with integrated physical and analytical
Okay, so I think the playing of the video would take longer bandwidth to play. Maybe I'll pause it now. Maybe I'll pause it. Okay. If you want to watch it later on, I can give you the link of this 4-minute video if you want to watch them. So actually, that one concludes the entire constructible process of the all about this. So in this, as you can hear in the video, but apparently not. So we exactly in the Trimble Connect is a system of interacting software, hardware, and services. So it's not just about the software, hardware also, like the Trimble navigation, the scanning, the laser scanning, also this, and plus of some of the services cloud, like the cloud services that we offer. So these are completes the entire processes. So as you can see here in here, it could estimate, improve, and confidence. You do the estimation, and then the data, since you have a better quality of the model, you have the data accuracy that you can able to bring with. So it started with constructible, and then it goes to the content enable, and then connected. So they are all these three discipline, we call it 3Cs, complements to IDD, or so-called integrated digital delivery. So yeah, so this is the our process is built upon the open BIM. So Trimble, we are open BIM, and we are that is our main principle. So we simply use that data to liberate. So for example, this one's the BIM to data. The whole point of the BIM was to liberate the data, not in silo or not in proprietary format or software. Meaning to say, we in Trimble, we are not only dealing with our own format, but we are communicating with other BIM authoring tools such as Autodesk, Navisworks, SketchUp, ArchiCAD, and a lot more. So this BIM authoring tool has a different kinds of format that they are used internally, and in order to work continuously or streamline, we are utilizing an open BIM, this kind of thing. So if you see here in the screen, this blue person at the site at the office are creating a model, and then they pass it to the site in order to bring a much accurate information. So yeah, so this is one of our Trimble navigation equipment. Hold on. All right. Okay. Are you still able to see my screen? Screen has stopped and external display is disconnected. Let me stop again. Let me share. Okay. Sorry about that. Okay. Are you still able to see my slide presentation? Okay. Not with my notes, right? Okay. So So this is the three C's that I'm talking about, the constructible. Okay. Hold on. Okay, so this, as you can see in the left side, we have this actual model that was constructed. And then on the right side, this is a BIM model. They're exactly the same because they're actually built from BIM model. So, hold on. Notes. How to stop sharing. Sorry. Give me a sec. I see. Okay, this one, right? Is it now correct? Okay, thank you. Sorry, my apology. I'm not familiar with Zoom because we are using a different platform, GoToMeeting and some Microsoft Teams, but Zoom, especially in our corporate, we don't use them. Okay, so here, if I move forward, okay, this one is another example of, this one is taken from Sports Hub project. And as you can see on the on this screen, it was side by side modeled, exactly modeled that how the shape it is and how it was being fabricated. So we call it universal joint fork. This is one of the movable panel in Sports Hub. So yeah, so and then the other one, this is the entire assembly, but not the entire piece, but only like a delivery piece for you to be lifted in one shot. So they're exactly the same as the what was in model. Okay, so what is in the model can be fabricated. Here, this was taken somewhere in 2014, and then this is our actual model. Actually, I manage a group of very highly modelers at that time. Majority of them are Filipinos. So actually, Filipinos, like what Sir Lex mentioned, we are capable of doing a lot of things, especially when we handle about technologies. There's many other countries, but Filipinos are way beyond that. Yeah. So this thing is the side stage, and then I put it side by side with the project. So they are exactly the same. So imagine if you have built your project in BIM and then you found out some issues, you can immediately avoid kind of issues before it was happened. So you can predict them. Okay, another one. The reason why I only update this slide just now because I saw Sir Lex a while ago about the truss block. We call it truss block. Actually, this piece, the one that is, we have this a total of almost 16 of these side by side, and this quite is massive. And these are the one that holds the entire roof. And imagine when we build this, the height of the roof, because of the weight, it exceeds 50 millimeter gap. So we need to accommodate that. So without using BIM, we may not able to accomplish any of this. So yeah, so this is one of the, just to share with you. So in short, this is the constructible model on a high level of detail. So traditionally, in the left side, we are using a CAD provider. So I'm not saying about 2D AutoCADs, but there's a lot of, not all 3D softwares are so-called BIM. I think it was clarified clearly by Sir Lex a while ago, this morning, that not all, there's a lot of 3D software. AutoCAD has a 3D functionality, but they are not considered as BIM softwares. Why it is become BIM? I think he also mentioned about the word itself, which is information. So building, information, detailing. Modeling. So if you have the building and the information attributed to that geometry, and then you have the modeling. Then these are called BIM. So you can able to down to the last bolt. You can put it everywhere there. Put embeds, mechanical, all the rebar, and then you consolidate all of them in one detail, and then it will. Since all of them are in one entity, you can easily determine whether what need to be avoid, or maybe to consider during the BIM modeling. So yeah, so this in Trimble, we are in not all BIM softwares has a very high level of detail. If I'm not saying because I'm from Trimble, but Tekla is the only one who could do a very much high level of detail, even to the last bolt. Okay, so even to so tiny details, so we model that functionality. Okay, so another thing is here. A while ago, this morning, Sir Lex mentioned about the augmented reality. So the augmented reality also is parts of the constructible, wherein if you want to visualize what has been done at site, and then you have the BIM models with you, we can use this information to bring that information from cloud down to this device. We call this Microsoft HoloLens. Actually, the hardware itself was built by Microsoft, and then as a Trimble, we partnered with them to develop we call it Trimble Connect for HoloLens, or SketchUp for HoloLens. So if you're interested, maybe we already have coming the HoloLens 2, especially here in Singapore. A lot of companies here in Singapore see the potential of the augmented reality, because once they see it and then they go to site, especially you cannot do measurement from site accurately. Maybe for some obstruction you cannot do measurement. You can use the HoloLens to overlay the model and see for yourself what are the issues that may arise before it was happened. Okay. So so that is the constructible. So the connected is the connected constructions is how these different disciplines can work together. You are one guy is working at the shop, the other one is at the site, the other one is in the owner side. So of course, all of us are using different softwares, right? So on our different native format. Native format, it means that if you are a contractor or if you are a consultant, you might be using a engineering software or analysis software. If you are a steel fabricator, you are using a steel detailing software. So all of you are using different kind of software. So how we do in Trimble here is this Trimble Connect. In Autodesk, this is similar to BIM 360. So Trimble Connect is where you can put all of your discipline in different respective stages, and then you communicate with the cloud. Later on in the later part of my presentation, I'm going to show you some quick workflow for Trimble Connect. After we model, we create drawings, we create reports, and then we will going to do this Trimble Connect later on. All right. So hold on now. Okay, here the Trimble Connect. So the Trimble Connect is an application or construction collaboration around from 1D to 5D project. So imagine if you have a Google Drive, if you mentioned about a while ago, Google Drive, and then you have a file management that can store data. At the same time, you can also able to collaborate and exchange information without moving from a different software. Meaning to say, you don't have to purchase if you are a consultant, you don't need to purchase Tekla structures in order for you to view their model. You can communicate with Trimble Connect and then use a we call it IFC or the Industry Foundation class format for you to be able to view this model. So these are one of the functionality. You have the data management like a Google Drive, plus coordination or creating class detections. You can also able to do some of the RFIs instead of these are the old traditional way. But in Singapore, majority of us are using BCF tool, or we're in instead of creating an RFI, sending attachment to the emails and then waiting for the other party to respond. Here, the Trimble Connect can do all of this without moving any of this kind of traditional way. You can create comments directly from the model, and then when you tag their email, they will automatically receive these kind of notifications instantly. So later, I'll have a quick demonstration about the Trimble Connect workflow. And okay, lastly is the content enabled. Okay, content enabled. This is where the since Tekla Structures has many component catalog that you can use from. We are when we started, we are only focusing on steel segment, but way back almost 10 years or 12 years ago, we already starting doing even concrete reinforcement. So yeah, I started from steel industry, but when I joined Trimble, I also now doing a lot of rebar, concrete, precast kind of things. And then the good thing about this is inside the Tekla Structures, there's a plenty of catalogs, components that is readily available for you to choose from. Or you can also visit our warehouse. We call it warehouse, wherein if you are on maintenance, you can able to download all of these items, and then you can use them. Like for example, if you are a PEB manufacturer wherein you develop pre-engineered building tools like build-up plates, instead of creating them individually, we have these plugins that you can able to utilize them without creating from scratch. So these are just few, but there's 1,000 millions of component that you can choose from concrete, from formwork. Okay, formwork, to those who, I think in the Philippines, majority, I see a lot of like scaffoldings, but here in Singapore, there's a lot of precast projects that was enforced by the government to, and then one of them, in order for them to give a better score, they need to develop this kind of formwork tool wherein they can make it much faster than the normal traditional way. We have transmission towers, even the bridge as well. Yeah, that you can able to use. So all aspect pertaining to steel and concrete. Okay. Yeah, so this is just some of the case study from a previous company, but most of these are from Singapore. In the Philippines, we have since we have our own in the Philippines, we have our own reseller, the VTS. They are much. They have. They do their. I think you might heard about them. They are the one who do all the things. As in Southeast Asia, we Philippines is one of our resellers, the VTS. Okay, so we also do open API. Yeah, so that's it. These are just some of the companies in Singapore who, to name a few, but we have many, but these are the big names that you might be aware. The Arup, the RSP, Arup, majority are airport, okay, Semcorp, Becca, so Worley Parson. These are few who use these softwares. And then here we have this kind of project also that that we utilize all of this project, and part of them is also the sports hub in the BIM Awards. We have this so-called every year we launch a competition for different segment. Either you are a student or small and medium enterprise company or a big company, which whatever discipline, we create a competitions across the globe, and then we sort it out from region Southeast Asia, and then we move it to global. Okay, and Sports Hub, when we do that, we are the 2014 BIM Awards last time, 2014. Yeah, so that is the that is my quick. I don't know if it is quick. Okay, that is my short introduction for the overall Trimble Tekla Constructible BIM. So you already know what is Trimble and what is Tekla, right? So let's now go to my model simulations. Okay, let me move on. Okay, so these sessions, if actually you can if you don't have any Tekla structures with your company now, or if you're a student, you may visit our Tekla campus. Okay, here you can I don't know if you can see my screen. Can you see this screen? Can you see this? Are you seeing the one I typing, Tekla campus? Anyone can see my screen? Yeah. Are you seeing the Tekla campus, tekla.com? Yes. Okay. This Tekla campus, any of you can able to use them. Please, you must register. Either you are a student or maybe you are a practicing. These are free. You can use them up to 4 months free usage. But take note, this is only for training purposes. Okay, you cannot use it or for your commercial project because there's a watermark, right? So if you visit this website, campus.tekla.com, maybe I paste it here in the chat group. Okay, can you, yeah, visit this, just follow the steps, create your account, and then activate, download, and then yeah, you can straight away, you can able to use your software, even your personal computer. All right. So if you can able to follow me afterwards during my presentation, then much better. So here, so let's start now. Okay, I'll do this one is a product simulation demonstration. Our intention for today, for this session, is I'll be showing to create a quick modeling. Started from, let's say that the workflow is you receive a model from a consultant who uses Tekla structures for their analysis and design. So this could be a stick model, and then how you're going to proceed on this aspect. Okay, so from here, what's the time? Can you hold on? Okay, still have. Okay, so here, so this is the Tekla structure 2021. Okay, and then basically this one you need to install in your computer. So from here, let's say I receive a let's create a scenario wherein, let's say Sir Lex is from the engineering consultant. He uses a BIM model for them to create an analysis in order to create what is the sizes and what is the height of the beam and the column. And then I am from the consultant, I am from the fabricator who will going to further develop the model into a constructible model. So I'm going to receive a file from him. So this file could be an IFC. Okay, so IFC is the common format file to communicate with different software. So I copied this link. So browse. Okay, so here I'm going to open them. So okay, good thing about what Sir Lex mentioned about the previously, we have this so-called project base point. Project base point is here you can use your own model origin, but if you want to communicate with other entity, of course this architect might be using a project base point, meaning to say maybe the project was been located somewhere in Luneta, right? But since you are a fabricator, you don't worry about that. But since you are communicating with the project, you will going to pass it to him, this model, to further for coordination purposes. So both our coordination should be, the coordinates should be the same. So that's how. So okay, so if you see this, right? Can you see my model, my 3D model? Let me know if not. Okay, so here. So from this, if I click this is one entity. By right, I cannot amend this model. I cannot modify this model because this model was from a consultant. So in order for me to utilize this to be my Tekla model, I need to convert this into my Tekla native file. So if I select this, if I inquire this is basically an IFC format, which is came from a different software. Okay, so here we can let's convert this into IFC, right? So here you can, instead of creating from scratch, you can utilize them and then convert them into native object. Okay, so now it's done. So everything has been converted into my own model. So I'm going to hide this now, hide, right? And then apply. Okay, so here, they looks exactly right. A while ago, they are gray. If I turn on this, it is overlapping with the IFC model and then the Tekla model. So there's a two model here. One IFC came from a different software, and then the Tekla model that's why I converted. Okay, here, so basically you have this model now. So first thing to do is you need to select the grid line to be correct. So you can either drag this grid line, right, in the position that where you want to put, or you can double click this grid line in order to modify the coordinate value, the x, the y, and the z. So this is basic in terms of even if you are using an AutoCAD, you need the x and y for you to where you put all of your items. So good thing I already saved them, so I don't have to manually input. So this yellow are the new value that need to update on this grid. So you see now it is now matching with my model. Then I going to fit work area. Okay, so this is now the model that I am going to do. But you can also create a groupings. Let's say I want all my columns to be red. Okay, and I want all my beams, these supporting beams, but not including this slab, to be let's say different colors. So class can be normally when we do this color coding is whether they are the same name or same profile. Okay, let's say for this one I'm going to make them maroon purple. Okay, and then all the beams here I can also able to select here all the beams filter, and then from here okay, all this beam but not this. So give me a sec. Then I'm going to change it to a dark green. Okay, and then lastly, all my girts or purling, let me put it, all my purlins, I'm going to change it to cyan. Okay, and then yeah, so these are just, and then I wanted to change all my slab to be gray. Okay, so just to make some tidy okay, then right, and then after this what I need to do, so I'm now starting to put all of my footings. So here if I inside these Tekla structures you can do steel, you can also do concrete. So let's say of course we need pad footing in order to, okay, so you can put pad footing. Okay, so you can either copy them or select them individually. So if you are an AutoCAD user, you don't have to worry because the functionality is almost the same as how it was being done. Okay, so if you have the Tekla Campus, you may now able to use them now if you want. You can side by side install that and then do a simple demonstration. Okay, I don't have this. Okay, so I have this. The good thing about the shape here, you can, okay, after I do a basic stick modeling out of this, let's create a detailing connections, right? Let's create a connections. Okay, let's create the connections out of this. So let's say this footing requires a, okay, here. These are the library that we can use them. You don't have to create them from scratch. So pad footing, and then you pick. So once you pick the concrete, it will automatically create the reinforcement based on that shape, based on the cover thickness. You know. So if I double click them, so you can either since we are, is there something? Sorry, so since we Tekla structures are more on, this is our strength. So here you can specify the cover thickness. So the top cover thickness, the bottom, whether you also what is the size, the grade, you can specify the grade. By the way, in we uses here the BS 866 or the BS 4999. This morning I saw Sir Lex mentioning about the international standard. Since we are in Southeast Asia, our standard here, we are following the Southeast Asia environment, wherein all the necessary grade, material profile, and all the codes are listed in this Southeast Asia. So if you are working with other country like Japan or China or US or Australia or Canada, wherein they have a different code, then you should download this environment separately. So this you can download this separately. So far I have this UK, Southeast Asia, and yeah. So basically, yeah. So if someone asks you, is the A37 material grade is here? Yes, there is. You can. If I go to this, so far if I go to the material in catalog, you can specify the material, either A36, right? Or maybe A500, S275, and yeah, all the materials you can able to concrete them. Okay, concrete, catalog, and so forth. Right? So here, so you can either change the angle. You see the bend. You can change the bend, either 35 or you set 90. Right? And then the secondary, you can also change it to even the spacing. So everything can be modified here. 135 or maybe 180. Right? And then here, once you modify this item here, if you drag this, it will also behave in a way that it is intelligent. It follows the logic of the cover thickness. So you don't have to worry about what happened if there's a design changes and it was changed to a different number. The component behave in a way that logically, if you extend them following the cover thickness, it follows too. So okay, so just a quick one. So I can either select this component. I can click everything. You just need to, if I want to copy this functionality, just double click and then I can apply them, and then let me apply. Apply means I wanted to apply all the bending following with that logic. So let me delete this. Okay, I can highlight. You see, it follows. So if I'm going to highlight all of this, highlight. See how easier. You just need to highlight everything and then it follows the logic. So let me delete. This one is not needed. Right. So I'm done with the footing. You can also add a strip footing if you want. Here. Let's say this strip footing. Here. I'm sorry. Let me pick one. Say this one only. And then you can, we have this split functionality as well. Let's say, let's split this because this should be stopped from here. Okay, now it's split. Click and split this. Sorry. or I can, they are now split, or I can copy them so that they will be the same as my item. Okay. Same thing, strip putting. You just need to click this. Then you have the reinforcement. Okay. If you have a different type of sizes, again, you are free to modify them, whatever you want here. You can modify the component. Okay. So let's go to the base plate. Okay. Let's say base plate. This thing. Sorry. I click this. Hold on. Okay, so this base plate is just pure base plate. So I can either modify this component to create the anchor. So everything is here. So I can go to anchor, change it to anchor, modify. Okay, and then you can see that there is now an anchor. If you want an actual anchor, then you specify this, right? And you want to put the nut and the washer. Okay, and then if you want to apply this and then to copy to the rest of the item, you can do that. So either you right click, copy to another object. So right, so you only do it once and then everything will be copied smoothly. So you don't have to be repetitive creating them. Okay, so right. So now we are done with the footing. So I'm now going to the these connections. Okay, so this column and beam connection. So let's use the hunch. So hunch connections, eaves connection. So if I double click, normally you can see here the property that we need these two items. The blue you need, the yellow will be automatically created. So I just need to pick here and pick. And then if you click here, it will automatically create the connections, the end plate, and then the hunch. Okay, let's say when you double click this, of course, you can specify whether you want a the users has the ability to modify all of the informations. What is the size of the end plate, the red plate, the cap plate, and then even the parameter. Let's say I'm going to change this one to the bolt. Okay, you see this one, the bolt rafter. Currently, this bolt, if I'm going to measure them, this is a 90 pitch. Okay, or if I'm going to select them first, I can measure this bolt with respect to the end plate. Currently, this is a 100 by 60 roll edge, and then the shear. The shear edge is 60, the roll edge is 70, right? So let's say we let's change it to 120, and then instead of 5 bolts, I'm going to change it to 4 because I'm going to use the M24 size. So you can use the 8.8, which is the normal 8.8 standard bolt. So if I click this, modify, it will automatically change the property. So even you change the so even here, but I will not change the 60 anymore. So if I redraw and then I do measurement again, click the bolt, now it's become 120. If I want to change the edge distance, the roll edge from 70, I can make it 80 if you want. So if I click this component, yeah. So if I redraw, do measurement again. So this behave in a way that what you want. What you want is what you see. So yeah, you see 80 mm. So everything has been modeled. So if I'm going to apply this, right? Apply, redraw. So I can apply all of this as well to the rest of the right here. Right. So okay, maybe I'll go with that. Okay, so let's say even this, even this type of connections, I can either use this component, right? The hunch. But since we have a component, we have a column, I can change that connection to extend this. Okay, and then change this rotation to a way that it's supposed to be 0. Okay, and then I can, instead of the hunch, I can use the same logic. Okay, so maybe I don't need to be change this to parameter to make it straight, right? Also this straight, right? And then from there I can move them to lower. Okay, so how convenient, you are modifying them inside the 3D. Okay, and yeah, so if you want to copy them the rest, and then we have this, some of the connections with the beam. Even here we have this beam to beam, we have a lot of beam to beam connections, right, to begin with. Sorry, okay, or we can use this automation. I can highlight everything, highlight, and then we have this component that is create auto connections based on the predefined. Let's say use the portal frame logic, and then I use the factory cuts, or meaning fit only, and then I do, it applies both the connections framing conditions, beam to beam, beam to column, beam to flange. We let the auto connections behave. Okay, apply. Okay, hold on. Okay. Okay, see this, right? Now, okay, you see, it is now built in one go. Right? I don't have to worry about all of the connections, even the beams, even the beam connections. Okay, it's now created. So it is good, especially when you do a calculating only the MTO, the material takeoff, or maybe the QTO, quantity takeoff. Yeah, there's a lot of names, but you can specify that, right? So these are the connections. So even for this, you can also change a let's say rolled number with sleeve, rolled sleeve. So let's say rolled sleeve here. You can so everything can be hold on. So this connections is applying. See the image. So if I connect this beam to this one, then middle mouse, it should able to create a what's the size of this? Give me a second. So, okay, let's say this. Oh, hold on. Give me a moment. So this one's supposed to be a, is it 220? 250, sorry. Here, you see the 250. Then if I apply this, give me a second. Okay, here. If I apply this, and then if I continue doing that work, I just need to, right? You are creating a component, only one go, and then you will specify that. Okay, and then for the other side, if you want, you can select the two. It will create connections. So it's quite intelligent that we do the things. Okay, let me find a way. Okay, I can completely do all of, sorry. Let me avoid some of the, okay, I can do all of this, but I think for the sake of session, it would take a while, but maybe let me do. So you just need to copy or pick. Maybe this connections is different from the other. So, right, then we draw. Right. So let's say only this. So now I will not going to complete all the connections, but if I plenty of time, I can complete this. So let's say now, we have this model now that has this 30 connections. Okay. Now let's create this view. So compared to AutoCAD, you create view, plan view, elevations, view elevations, north side, and then later on you stitch into 3D. In Tekla, they are different. We started in 3D, and then all of them you are now able to generate different views, plan and elevations. So we have only one view. Hold on. We have only one view currently, Then I can create a view automatically. Give me a sec. Okay, you see this? Now, let's say if I want to view the grid line 2, here I can view the grid line 2, right? So if I click this, I have grid line 2. If I want to view the grid line C, okay. All right. Okay. Tekla structures is more on the physical modeling, not analytical model. Although we have this analysis in design, someone has a questions, I can right away able to answer them. If it is a analysis in design, we can able to bring a self-loadings only. But to calculate the forces and the sizes is not this software. It must be the Tekla structure designer. So different software. Okay, but they are family under Trimble. Okay, so we have this. We have this import Tekla structure designer, wherein you are able to import the analytical member from Tekla to designer, and then you can able to calculate the forces and able to change the sizes as well. Okay, but these are fixed considering that you already designed the member, and then you just only furthering do the detailing aspect. Okay, so we don't have the analysis here so far. Okay. Yeah, okay, so this one, so I have this several view. So we never created these elevations, this grid line C, but they are automatically created once we finish the model. So using this logic, we can create drawing straight away, like the marking plan or general arrangement for easy access. So we are now with the modeling aspect. We're in and now we will now move to basic drawing and creations. Okay, so let's start with this. Okay. Okay, so let's start with this. So I'll close this now. So let's say I choose this view, right? I right click this, right click, create general arrangement. So I can choose which view need to be incorporated in one drawing. So to those who don't know about the general arrangement, this is like a marking plan. I forgot what's the how we call it in the Philippines. I think it's marking plan or erection plan. Erection, because when we moved to Singapore, I think Sir Lex would understand this. It could be now a marking plan or general arrangement plan. We have a different name, but the concept is the same. In order to view where is the assembly, either whether you wanted to erect them at site or to determine where they are exactly located at the site. So that's the logic. So let me select 3D grid line 2, grid line C, and then the first floor. And then I'm going to open them instantly. Then later on, we will do the assembly drawing wherein all the quantity takeoff will be generated. Okay, so drawings has been created. Let's find out where is that. Okay. Can you see my drawing? So if you are AutoCAD users, so a black background, right? So this seems to be an AutoCAD, but they are not. They are we call it 2D mode in Tekla structures. So I have this 3D, I have these elevations, I have this 3D. So you can able to drag them like the way that we do in AutoCAD. So let me move it a little bit. So let's see the scale. All of the scale is 1 to 100. Okay, all of these 4 view are 1 to 100. If you want to change the scale, you can right away click 150. The bigger the number, the smaller the size, because they are 1 over 150. Okay, so this is, although I can still able to see my model side by side. If I click this, it highlights, right? It highlights my model. I can view them. I can see them where it is. And let's say I wanted to click this, inquire. It highlights because they are linked. Okay. Once you delete that object, the drawing will also delete it because they are live model that they are live model. They are not just drawing. They are BIM models. Okay, so they are linked. Let me expand them. Okay, so let's say on this exercise, in this demo, I'm going to create how quickly we can able to, at least somehow, not to be quite presentable, but how we can generate the sections, the elevations. So let's say I'm going to start with this view, right? Of course, we have this info. They are the same. Also, we're only doing some quick representation. So here, I'm going to create a detail view of this. And then the detail view is similar to your AutoCAD. Imagine if you do it in AutoCAD, you have to draw them separately. Either they are not scale or maybe not true scale, right? Okay, there's a welding. Why? Because there's a welding in the model. But for the sake of our sections, let me remove the welding for the meantime. Give me a second. Okay. Weld mark. Okay. They are show, so I'm not going none, and then modify, apply. Okay. So for the meantime, let's hide them. Okay. So basically, the size of these, the blow up is basically larger than the what it was came from, 25. You see, when I click this, it highlights, right? If I drag this cone, you see, if I drag, you see the bottom, it also moves. If I drag this, it also move the way this. So they are linked. So if you create a blow up sections on this area, you will guarantee that they are exactly the same. So because they are one model. Okay. So they are detail A. And let's say if you wanted also to change the appearance to make it rectangular, hidden, and then make it a blue one. Sorry, blue, right? And then I'm going to hit apply, so that the next thing that I do this, it will automatically create. Blow up. Okay, so just a fine side by side, and then this thing. If the scale, if the scale is too big for you, so you can able to modify them. Okay, let me move it. If they are too big, then yeah, this one let me move a little bit. Okay, this one move a bit, move up. So there's a detail B. So you don't have to worry about the editing because they are linked. If I change it to a different name, it will also automatic. Here, if I'm going to change it to detail 1, for example, 1, it will also change to 1. So the logic there is you don't have to worry about where the sections came in because they are exactly the same. So let me continue. So do this, cut. I haven't done any markings yet. Let me complete first all the cuts and everything. So these are the common that we usually see, right? So cuts, and then we will perform all the, so probably they are the same. So if you wanted to create, these are section, detail view, but if you want to create an annotation that is symbol only, we have this mark. So they are detail mark. You can also create mark of your own that is the same, right? Here, this is not linked to anything because this is only an annotation. You can make it F, typical to E. So, or maybe just other hand, okay? And let me continue some of this detail, this one as well. Okay. Yeah. So I have these sections here. If you want to change the concrete, remember we modeled them concrete. Basically, they are also concrete in essence. Here, concrete. Hold on. I'll make it black and then change it to automatic. Yeah. Oh, it's custom. You see, it become a concrete because they are concrete, right? So I believe this is a strip footing, and then the other one is footing. Strip footing is the small one, so you have a multiple. So here, so you can create all of this, and then from here on, you can also able to create sections of this. So let's say create sections. So you can sections a sections. So technically, you can create a sections out of a sections, right here. And whatever the value there is exactly the same. What else? You can lastly here. I can do this view. So all the basic logic, and they're all linked, right? And then here, maybe this section from your anchor bolt plan, if you, okay. So yeah, so you have all the logic, all the necessary. If you want how to print, yeah, this is the printable. This is what it look like when you print them with layers. If you have monochrome, then this is what it look like, right? So you can able to view them. So let's now go to markings. If you want to go for this marking, let's say you just highlight everything, and then from there, okay, from here show you want to specify the annotation for what are the profiles. So instead of manually picking them, you can able to, okay, I want to get the profile for all my beams, okay, and then add mark. Okay, you want the mark, you want this column to be the same, add mark, okay, column, or you want all the purlins, okay, add mark, but it will show everything, right? But you can either create separately. Let's say you create this one, add mark, and then yeah, and then from there you can annotate. Let's say modify. You can here you can type here text. Hold on. Maybe let's say put it typical, since they are all typical. You can also put annotations, right? Okay, how about the arrow key also? If I double click all of this, and then where is it? Double click, and then if I want to change my arrow here, you can specify the arrow, right? You can hit apply, and then when you highlight the rest, it will also update the settings of all the cuts. So it's up to you whether what type of arrow key that you want. So detailing part, we leave it to the company standard. Okay, so if I want to window everything, and then I show, then I can put sorry, I will not include the 3D. Sorry. Okay, sorry. I highlight this, but not the 3D. Okay, show. Hold on. Okay, let's say I'm going to select only the by only the beam and columns and footings. Okay, highlight. Then you can guarantee that everything is the same, correct or accurate. Okay, so to those plates, yeah, you can highlight, show them the plates, and then you can specify the plates separately. Let's say all the plates, because we have the haunch and plate purling. So yeah, so this is just like a quick the information is there, we just need to extract them. So that's how the beam modeling tools is all about. So you model them in a way that they're accurate as much as possible, and then when you bring the information, they are actually what it is. They are not text, they are not. So if you change this model to a different size, then it will automatically update also inside this model, because they are model. Okay, so of course you can add a lot of dimensions if you want. Dimensions here, here, these are the basic, right? Quick one. So you will be avoiding the manual dimension. If there's a different dimension, let's say this, let's see, this one's supposed to be, okay, sorry, why is it there's a 0.5, something wrong? So this must be a whole number, right? So you can, let me update that. Basically here, because Tekla is accurate, the precision is 0.5. If you make it to 0, then you can make it full number, round it off. Right? So yeah, welding, everything, yeah, you can add welding if you want, especially if you let's say add okay, sorry, this is one level mark. The good thing about the level mark is you can determine the height. Let's say, wait, let me this. Okay, let's say click this. You see the height itself. These are accurate based on the model, so you don't have to worry about the level. Add level. Say this one. Grid. So you see the first floor is a 4,500 meter. So you can, they're all accurate. Sorry. Okay. So that's how the model all about. All right. So let me now going to export them. Let's say I'm going to export them into AutoCAD. Let's say for your submissions, of course, some submissions still do the 2D submissions. So you can submit them into AutoCAD, whatever the version is. Export. You can preview them if you want to see what it look like. Hold on. I should not preview. Okay, you see the yes. Actually here you can generate footing in the drawing also automatically, because these are whatever you model, you can generate drawing. Because here you can have the rebar and everything. Yes, if that's the questions, yes. So export. I never include the reinforcement, but yes, it can show the reinforcement, but yeah. So that is the AutoCAD, and maybe I'll put it later on. I'll go now to export them to PDF. So same thing. If I want to PDF, so I will not view them print. Let's see. So if I go to my model while I'm waiting for the PDF, yeah, see this PDF? Now it is now the PDF, so the one that we created. Okay, so the line weights. I didn't use line. I don't know this one with line weights because with shaded. Yeah, you see. Of course, you may have a better presentation if you do it nicely. Yeah, but that's what it is. AutoCAD. Now, if I go to AutoCAD, this one, you can still able to modify them in AutoCAD, but we don't encourage you to modify them because the AutoCAD is only for your submission purposes. But anything that can be done, edit, put text, line, must be done in the BIM model, because once there's a new changes inside the model, it will automatically updated. You don't have to worry about where did you submit the versions. Maybe it's revision B or revision A. So yeah, so although they are similar to AutoCAD, but no, a lot of AutoCAD will not be removed actually, because we are still utilizing AutoCAD as the main, like how to import, how to export. But yeah, hold on, AutoCAD is still opening. Yeah, okay, so while okay, so this is the AutoCAD. Okay. Okay. So this is what it looked like in AutoCAD. If I zoom, extend. Okay, here. So if you notice there, because it is inside the model, it is came to a different entity, right? but you don't have to worry. If I go to, hold on, if I go to layout, it's still in the paper space. Yeah, here. So you can move the paper space in all of this if you want. Okay, here. Like for example, here, if I double click, like how the AutoCAD works. Okay, then I can move, right? And because these are inside the model. Escape. This one here. So you can drag or you can want, but I will not do that because anything we don't encourage. We discourage you to modify them in the AutoCAD because anything can be added. Lines, circle, anything you can add them inside the Tekla structures. Okay, so this is the AutoCAD output. Let me close them. Okay, so now we are now done with the general arrangement or erection or marking plan. I am going to show you the assembly, what it looked like. So let me close this. Okay, remember we have created the connections a while ago, and then we will going to utilize that connections. So let's say this beam, okay, here, I'm going to, if I click this member, if I click 3D, this is this connection. So this member has everything. So if I create a drawing, it must include also all of these attachments. So if I'm going to create a drawing out of it, maybe here, right click, create assembly drawing. Okay, let's remember perform. Okay, so one drawing created. Let's open the drawing. Okay, so you see this one, A. G stands for general arrangement. A stands for assembly drawing. So if I'm going to open them, using the default drawing template. Hold on. Okay, you see this? You see this what it looked like? There's a basic front and top view and some sections. Although you can alter modifying all of this depending on what type of detailing standard you may need. But this is out of the box sections. You can change this one, but the good thing about this is this: the bill of material. You don't have to manually edit them in order to calculate the size of the beam, the material, the profile, what is connected to that assembly. It will automatically generate for you all of this material list. Okay, so the area, the weight, they are accurate. So whether you have some notes that is unless noted, how many beams the drawing mark, A47 is the mark, where it is, what is the quantity, what is the phase. So these are the basic information that you can have. So this is assembly, right? So if I close this, and then let's say let me create the column. Okay, this column, let's say I modify this connection. Sorry, I modify this connection. I'm going to put sorry. Maybe this one. I'm going to create drawing, assembly drawing for this column, together with all the stiffener and everything, plus the base plate, right? Base plate. So if I click this, I should see another beam, another column, assembly. If I double click, okay. So I have, I don't know, not this. Hold on, it must be this. Okay, you see this? I have this column with the attachment, where it's the location, the detail. So this is out of the box. So you can still perform a lot of ways here. You see the material here. So this is all attached to that object, to that column. So you don't have to worry about. You model them as accurate as you can. Actually, not you can. You must, in order to generate a correct or a consistent output. So you must model them. Okay. So we can select everything. Let's say this one is without just stiffener. Let's say I'm going to modify this. and I'm going to add closure plate. Here, I'm going to add a parameter that I can add the closure plate. Before it was not, modify. Now it added this stiffener, right? So if I'm going to open that same drawing, sorry, hold on, let my screen change view. Let me stop my screen again. Give me a moment. Okay, hold on. Hold on. Let me, my connection is update. Okay, so hold on. Okay, let me drag this. Give me a second. It was. Okay, let me open again my model, and then I think it was hung. Give me a sec. Let me stop sharing first. Stop sharing. Give me a minute. What happened? Wait, Okay, anyway, my other model doesn't appear in my screen. So, good thing I have this backup. Let me share this screen. Okay, although this is different model from the way I did, but this is exactly the same. Only thing, I don't have the drawing, but let's say I added already. Okay. Can you see my screen? The one that this model, the one with the green, not colored one. Can you see? Okay. So let's say if I wanted to create a single part, let's say this plate. Oh, I cannot select also. Okay, here. If I'm modifying this plate, here if I select this, I think I need to restart my Tekla. Sorry about that. Let me restart my Tekla quickly. Quickly. Maybe 2 minutes only. Okay, restarting. Give me a sec. Opening. Anyway, the only thing left here in here is to create the single part, and then we will create a report. We generate report, and then yeah, we are almost done. Hold on, give me a sec. Yeah, okay, close already. Hold on. Okay, let me open again. If you have any questions while I'm opening my model, you can ask me a question now, if you want. I can answer questions now if you want. Mhm. I would like to remind you that we'll be having more minutes. Yeah, 10 minutes. Okay, while I'm waiting to this model, all right, okay. All right, okay, so where are we? Okay. Apology for that. Footings, it can be also modeled files. Yes, yeah. We have this file component as well in the component. If you click here, we have this file, yeah, file concrete foundations, and then you can also able to create a circular reinforcement out of it. So file cap, file reinforcement, yeah. So here, so let me go for the single part here. If I click this object and then I create single part, so you have a assembly drawing. Then if I go to here, SW. So this is the so-called the production cuts, wherein all the necessary information of the how it was being going to fabricate, and the grade, how many quantity, the length, and the area, and the surface area, or maybe you wanted to blast them or paint it with galvanized, so you can get the area and the weight, and where it is assembled, which assembly mark is connected to. Okay, so that's the thing. So let me move forward. Okay, we are running a bit. Right? Okay, so after that, okay, here you can. The next thing to do is to create a report, right? We have this bunch of reports that you can generate. Let's say material list. You can specify all of this. Let's say all the material, and then from there you can get the information, right? The weight, how many information, the length, and the weight. So these are the out of the box. We have plenty of these report that you can choose from. Even the bolt, the pile, the rebar list. Okay, even the rebar. Let's say if you want to calculate the rebar rebar list. Yeah, you see the rebar also together. How many? What is the bending? the bar bending schedule, the BBS, the bend, so you can specify. These are out of the box, or you can use our organizer, wherein this is also part of the thing inside these Tekla structures, wherein when you highlight them, it will automatically populate for you. Okay, so I think I'll move quite fast now, so I'll minimize this. So I'm now going to the quick. Okay, so are you able to see my screen here in my PowerPoint? Are you able to see this PowerPoint? Can someone do that? Okay, there's a maybe later I can answer you about the Campus Tekla license later. Okay, so here we have a collaboration with Trimble Connect. So like I said, you have a different stakeholder, different discipline, different formats, or different kind of files, whether they are 2D or 3D. So how we can encounter, how we can able to do that. So using the ecosystem of collaboration, we call it Trimble Connect. So it is a global cloud-based platform, but not only cloud, but they also have this window-based, mobile-based, wherein you can communicate all of this in synchronized information without the use of this authoring tool. When I mention about authoring tool, Tekla Structures or Revit or ArchiCAD or AutoCAD, you don't need this software to be installed or to view these informations. You can view them using a Trimble Connect. Okay, so and then we have this Trimble Connect, like I said, the web, which is I'm going to show you a while ago, and then the iOS, but I don't think we can. You can download from our Apple Store, or you can in the Android Google Store to download this Trimble Connect. They are free, and you can, like I said, if you're in the HoloLens, you can also able to view your model. Whatever we have modeled inside the Trimble Connect, can also able to view in the HoloLens. The Connected Visualizer is where they are like a rendering tool, but in a much lighter images. Okay, and then yeah, this is what I mentioned a while the Trimble Connect Visualizer. Yeah, you see this? It's not. This is a 3D engine built in Tekla Structures, wherein whatever you have modeled, it will convert into this kind of visualizer. So if I'm going to switch my model here, can you see my model here? So if I'm going to select here, visualize all, can you see my model? If I click this using the model, it will can you see this? It will create a image. You see the quality of this. If they are steel, then they are made out of steel. Okay. If they are concrete, then they are concrete also. So you can also able to view the reinforcement. Right? So this is the and then you can also able to you can also able to create a quite nice hold on. Okay, and then here, hold on. You can click the surface. You can drag this. You can change the sunset. This is including the software as well. Here you can adjust the yeah. If you can change the appearance if you want. Yeah. So you can even create an image out of this. Let's say. Maybe no need. So these are the Trimble Connect visualizer that you can able to utilize inside the Tekla Structures. Okay, so let me put it back. So the Trimble Connect HoloLens, yeah. If you're interested, we can check you out with our reseller in the Philippines, VTS, to have these demonstrations or maybe some quick on how to use this Microsoft HoloLens at your site. Quickly, this one, the property set library. What it does is when you bring them inside the Trimble Connect, of course, you cannot alter them to change into your own informations. Here, this property set can able to create outside of BIM and then you can add like this submitted, in assembly, galvanized. You can add these informations inside your properties. Okay, and here the content browser as well. When you upload your model, you can able to view as well all the properties necessary. So you can either sort, group the model, you can interact the model, you can colorize, you can select the model. Of course, you can also export to CSV, Excel, all of this into, so that you can populate, extract the informations. Again, the model is high information inside the they're a bit high LOD, and then the more information you have there, it's just a matter of extracting the informations using this functionality. Also, unfortunately, I don't have time to show you how it works in real, but this is what it looked like. You can simulate a status sharing between, let's say you have the office and you have the site team. Since the site team don't have any Tekla structures for them to view, what they can do, they can use their mobile phone, they can use the cloud base, they can put color-coded whether whether that item is already submitted or completed, and then instantly the guy from the office, they can able to see right away what is the status. Imagine, let's say, if your colleague, there's a design changes from the architect or engineers, and then you wanted them to view, to check whether are we still able to amend them at site. We can still able to button. If it is small, we wanted to make it long, we wanted to button. So this kind of scenario. So you can see this kind of statuses, whether to check. So this is not only from the site, but also in the productions. So without the use of Tekla structures itself, but Trimble Connect, you can view them. Okay. This one is what we do in currently here in Singapore. Because we are into the IDD, so we have this so-called status tracking dashboard, wherein you can able to view especially if you are a precast contractor, you wanted to check what is the statuses or the progress of your item using the Trimble Connect as well. Okay, so I think before I end this topic on mine, allow me to show you one video, and then after that, okay, here, let me show you. Okay, this video is the how we do in the sports hub. Okay. Hold on, give me a second. Okay, can you see the screen? Can you see my screen? Let me know if you can hear the audio. Can you see this video? It was published last 2015, 1 year after we finished with the project. And this is the word line just spanning the whole world. And we are the best steel project. This is Yongnam. This is my previous company.
From the start, our main business has been steel construction. Starting from small structures, we have expanded our business to more complicated and bigger projects.
Today, as you will appreciate, more than 95% of the projects that we undertake are modeled and documented using a Tekla structure.
The sports hub, a stadium which at first glance seems simple,
6 years ago.
but in real life, a very complex structure. Around 60 different connection types are employed to join more than 25,000 unique elements with 2,700 distinctive nodes on each end. Before construction happens, BIM model carrying live information which enables project parties to identify and solve issues already in the coordinated model.
Yeonnam has collaborated extensively with the engineering team, and through this collaboration, I think we have been able to model the entire structure as well as to include the connection and joint details.
The major point of roof structure of sports hub is the coordination of structural parts and mechanical parts and ME service parts. We prepared the model of structural parts. The mechanical subcontractor prepared their own model. We integrated this model in one model.
One of the key benefits of the Tekla structure is its ability for both Yeonnam as a contractor and the engineering consultants to visualize the problem. Now, this feature has resulted in a very fast turnaround time for solutions, which in turn has direct time savings advantages for our modeling and fabrication drawing generation.
Aside from technical sort of things, it also plays an important role in enhancing the productivity of our operation. It helped us greatly in reducing time for profile cutting. Thousands of bracing pipe enable us to set out the geometry in right pull approach in the workshop accurately, as well as loading it safely on the transportation while getting the COG directly in the BIM model. It also enables us to predetermine constraints on the public road and condition how to transport these massive trusses, which leads to the delivery of the goods to site accurately and in a timely manner. It also allows us to foresee any erection difficulties as well as possible clashes during erection, while analyzing a good solution to prevent them from happening.
Yeonnam needs to take more advantage of the other features that Tekla structure has, especially in the field of CIM, computer integrated manufacturing, productivity improvement, and production management. And we feel that we can use Tekla as an integral production tool above and beyond the requirements of BIM.
The power and the flexibility of Tekla structure, not just in 3D processing, but constructible BIM-based model. So powerful you can even create design into reality.
We have been using BIM for a long time, so now it's very difficult to imagine the system without BIM or Tekla.
So those are my previous bosses. Yeah. I think that's it. Thank you, everyone. I'll pass it to, thank you.